Hello students, welcome to all of you in my YouTube channel. In my last lecture, I discussed the electric field intensity. This chapter will for class 12 physics. Now I will discuss the concept of dipole and due to the dipole what will be the electric field intensity. Before that, I request to all of you to subscribe my channel so that all my videos you can see it. Now, I have given in my previous lectures what is the electric field, what is the electric field intensity. Before that, I also given lectures on the Coulomb's law, unit charge, like that. Now, I will discuss very important thing called dipole, electric dipole, electric dipole. The name implies dipole. The name implies two equal and opposite charges separated by some distance form a dipole. That is, two equal and opposite charges separated by some distance form dipole. Two equal and opposite charges separated by some distance form dipole. Now, suppose this is charge plus q, this is charge minus q. That is two equal and opposite charges. Suppose I consider distance between the two charges is 12. 12 is what? Distance between the two charges. I consider this point is the center of the dipole. So, this length is what? L, and this length is what? L. This system is called dipole. The dipole moment, we will define a term called dipole moment. Dipole moment means what? Dipole moment means what? Charge into 12. 12 means what? 12 means what? Distance between the two charges. Distance between two charges I have considered 12, not L. Why? Only for mathematical simplicity. Suppose the distance is 2 meters. You don't take 2 into 2. You take 2 means 12. Distance 12. So this is called dipole moment. Dipole moment is represented by the symbol that is P. P is equal to Q into 12 called dipole moment. P is called dipole moment. P is called dipole moment. And one thing, dipole moment is a vector quantity. Its direction is from negative to positive. That is the direction of the dipole moment. So, dipole moment formula is this. Suppose if I ask you a question, suppose plus 2 coulomb minus 3 coulomb separated by suppose 0.5 meter. I can ask you a question. Is this dipole? What is the answer? Answer is not a dipole, because dipole means what? Two charges should be equal and opposite. But here 2 coulomb and here minus 3 coulomb. So it is not a dipole. It is not a dipole. So if I write down this plus 2 coulomb and this is suppose suppose this is plus 2 coulomb, this is minus 2 coulomb. Question, is it dipole? Is it dipole? Answer is yes. Answer is yes. Then if dipole, can you tell me what is the dipole moment? The dipole moment is equal to how much? Dipole moment is equal to how much? That is formula is what? Q into 12. Q is equal to what? 2. 12 is what? 0.5. So 2 into 5 by 10. That is 5 2 to cancel. That is answer is 1. 1. What is the unit of the dipole moment? Q into 12. Q means coulomb. Length means meter. So coulomb meter. Coulomb meter. That is the unit of the dipole moment. Now, very important question comes for your exam. That is, derive the expression of the electric field intensity due to dipole in the end-on position. My question is, derive the expression of electric field intensity E due to a dipole in end-on. End-on means what? Axial outside. End-on means axial outside position. This is very important question for your ISC, for your CBSE, etc. Very important question. That is, this is a dipole. This is plus Q. This is minus Q. This is the center of the dipole. Total length is what? 12. You have to find intensity at point P. P is what? That is axial outside. This is axis. Axial outside. And P is where? P is at distance R from center of dipole. P is where? Point P at distance R from center. Now, how to find intensity? I told you already at point P what I should do. Place unit positive charge. Already I have discussed. Here is a place a unit positive charge. Then electric field intensity at point P. Suppose I consider electric field intensity at point P due to plus Q charge. Electric field intensity at point P due to plus Q charge. That is what? E1. What is it? E1 is equal to 1 by 4 pi epsilon naught into Q. This total distance how much? This is what? From here to here R, from here to here L. So R plus L whole square. That is equation number 1. And what is the direction? A positive charge. Here is a positive charge. So direction of is this E1. Similarly, due to minus Q charge will be what? That is E2, 1 by 4 pi epsilon naught into Q by this distance. Total is R, this L. So what is it? That is R minus L whole square. That is equation number 2. I think students, up to this clear. I have not written it. Dot means what? The electric field intensity at point P due to charge minus Q is this. What is the direction? Is a minus Q, is a positive charge. Positive moving towards the negative. So that is the direction of E2. I think up to this clear. You know intensity vector quantity. This intensity this direction, this intensity this direction, opposite direction. So resultant intensity will be what? E1 minus E2. So due to plus Q charge, intensity at this point is what? E1. Direction is this. Due to minus Q at point P, intensity is what? E2. This is E1 and E2. I think clear. So now net intensity. So net intensity is what? Net intensity at P is what? That is equal to what? E2 minus E1. Why? Because these two vectors opposite direction. That is E2 minus E1. I think all of you clear? Now, so this calculation we have to do the calculation part of this. That is equal to what? That is equal to actually this thing. In my next lecture, I will discuss this full calculation. I am stopping my class here. Thank you.